Hey everyone, Dr. Walker here. This is the guided examples video for 226, simplifying capacitor circuits. Let's take a look at the steps to solving these types of problems. The first step is to draw the given circuit and label each capacitor. Let's go ahead and look at the example so that we can follow all of these steps while we work on the example. The problem says find the equivalent capacitance of the circuit. You see in the circuit there are 4 capacitors and they have been labeled with a number as well as their value. So the first thing is if your capacitors are not labeled, I find it really helpful to label them C1, C2, etc. So that's the first step. Draw the given circuit and label each capacitor. Next step is find 2 or more capacitors in series or parallel, redraw the circuit, and replace them with their equivalent capacitor. So we have to find either 2 capacitors in series or 2 capacitors in parallel. So pause the video and think about which 2 it's going to be. So hopefully you saw C1 and C2 and they are in series. You can see that there is just one wire connecting them with no junction in between. So once you find those 2 capacitors, then you're going to redraw the circuit and you're going to redraw them with those 2 capacitors simplified. So what I'm drawing here is my battery, my C4 is up here, my C3 is on the right. And then instead of drawing these 2 capacitors, I'm just going to draw one capacitor, and it's going to be the equivalent capacitor of these 2. So I'm going to label it C12. That's just my personal preference. That way I know it came from 1 and 2. Once I've done this, then I'm going to calculate this capacitance. And I'm going to do it right below the circuit. It's really helpful. It helps you stay organized. If you calculate the new capacitance right under the redrawn circuit. So when you're in series and you're trying to find the equivalent capacitance, what's the equation? Think about it. Look it up. So the equation is the one I call the 1 over equation. 1 over C12 equals 1 over C1 plus 1 over C2. Go ahead and plug in the numbers to calculate a value here. 1 over 24 microfarads plus 1 over 8 microfarads. And I'll tell you a trick. When I put these in the calculator, I don't worry about the microfarads because I can just put in 1 over 24 plus 1 over 8 in the calculator, and then microfarads will end up being the unit for the final answer. So don't worry about putting the micros in there. When you plug in 1 over 24 plus 1 over 8, then you're going to get 0.166. But remember that that's not the final answer because you have to take the reciprocal to get C12 by itself. So C12 is 1 over 0.166, which gives us 6 microfarads. Okay, let's look at the next step in our outline. We've done step number 2. Oh, actually, we just did step number 3 as well, right? We calculated that capacitance that we just simplified. So then, the final step is to repeat steps 2 and 3 as many times as necessary until we're left with one equivalent capacitor for the circuit. So wash, rinse, and repeat. We have a new circuit here. Find 2 capacitors that are either in series or parallel. Redraw the circuit and then calculate that equivalent capacitance. So take a second, try to do it yourself. Which capacitors did you find to simplify? Hopefully you found C3 and C12. They're in parallel. You see that C3 is connected to C12 with that junction in between, and C3 is connected to 12 at the bottom with the junction in between. So they're in parallel. So we're going to redraw the circuit. We're still going to leave C4 alone. We haven't messed with C4 yet. But then, instead of drawing these two, we draw one equivalent capacitor. So C4 is up here, and since this is 1, 2, and 3, I'll call it C1, 2, 3. And this is still our battery over here. So now we're doing step 3, which is calculate that capacitance. When they're in parallel, what's the equation to simplify? You simply add them. So C123 is going to equal C12 plus C3. Go ahead and plug in the values. C12 is 6 microfarads, and C3 is 4 microfarads. So we're going to get C123 is equal to 10 microfarads. And I forgot to mention this earlier, but hopefully you still have room underneath, because we're going to come back to this in the next video to do some additional analysis. So that's why it's very important to stay very organized. So, what do you think the next step is? Well, hopefully you guessed it. We're going to simplify one more time. We see now that the two capacitors that are left are in series. They're directly connected with just one wire. So we're going to simplify one more time. And it doesn't matter where we draw this final capacitor. There's only one. You can draw it anywhere on the circuit. That's going to be C1234, which is also C equivalent, the final equivalent capacitance. So the two capacitors were in series. To simplify in series, we use the 1 over equation. It's going to be 1 over C1234 equals 1 over C123 plus 1 over C4. Hopefully you kind of see the pattern how it works. We ended up simplifying in series and then parallel and then series again. Plug in the numbers. It's going to be 1 over 10 microfarads plus 1 over 5 microfarads. And when we plug that in, that's going to give us, let's see here, 1 over C1, 2, 3, 4 is equal to, what is that? 1/10 plus 2/10 is 3/10. 3 over 10, the microfarads on the bottom. And then we are going to flip it to get the C1234 by itself. So C1234 is going to be 10 over 3, or 3.33 microfarads. So that's our answer for this problem. That is the equivalent capacitance. Hopefully you drew down the circuits like this with the work underneath, and then in the next video we're going to work backwards, and we're going to come back to this to find other quantities of interest. See you then. It won't be long.